Hi, my name is Manish Gupta. I work at Microsoft as a principal applied scientist. I also work as an adjunct faculty at IIIT Hyderabad. And this work is in collaboration with Shrey and Pratyush, who also graduated from IIIT Hyderabad. And Shrey is now a student at CMU, and Pratyush works for Google. So this work is on hateful comment detection and hate target type prediction for video comments, and we are happy to present it as part of CIKM 2023. Why care about hate speech for video comments? That's the first obvious question. So video sharing platforms have, of course, promoted quick and easy to understand mass content distribution. And there are really nice comments that people put up so as to discuss the content being presented in the video. However, the problem is that some comments are toxic, aiming to spread hate towards a particular community, location, organization, or even an individual. Comments may look naive, but are hateful in the context of the video. By themselves, they may be just okay, but when you look at them in the context of the video, they are very, very hateful. Right. So here is an example. So there's an example of a video where there are some protests going on. Thousands of people protesting in Australia against COVID lockdown. And however, if you look at the comment, the comment is white people in their finest moment, and this is sort of hateful. Now, it of course requires a little bit of understanding why this is hateful. Um, so it requires context that protesting, which is the word that comes from the title, right? Violently, which is the word that comes from description, is being mentioned as the finest moment in a very sarcastic manner, right? So to link to white people, it requires knowledge that Australia has white people, which may be obtained either from the external information or from the comments themselves, right? Comment toxicity, if you really look at this particular comment, white people in their finest moment, now that comment is clearly not toxic at all as per the Perspective API. Perspective API just gives 25.68. Okay. So detecting toxic video comments is challenging, right? Hate via comments, it is challenging on three counts. One, hate via comments is understudied. Second, there is no benchmark data set. And it's challenging because of the nature of the comment text itself. Comments are very short. They're not self-contained. They're often very contextual in nature. They often convey hate in subtle and convoluted ways. And also, they need long chains of reasoning, even for humans, to be able to understand them properly. So that's that. Now, there has been quite some related work in the hate speech detection community. People have studied hate from several different perspectives. So people have studied different types of hate like sexism, racism, cyberbullying, victim blaming, anti-Semitism, sexual harassment, general online harassment, or specifically cyber hate for a range of protected characteristics like race, gender, behavior, class, sexual orientation, ethnicity, disability, religion, and so on. So several types of hate have been studied in previous work. People have typically depended on typical standard NLP features like n-grams, linguistic features, distributional embeddings in initial works. However, more recent studies use deep learning models like CNNs, RNNs, LSTMs, and transformer-based networks. Hate speech detection has also been studied using context. So besides the original text, people have also used other contextual information like user and network information, images, and videos. Now, again, when you study hate speech using context, people have, since these contexts are typically multimodal in nature, people have used either just unimodal models or multimodal models. Unimodal models, of course, use CNNs, LSTMs, or BERT to encode text, but then they use other models like ResNet or Inception V3 to encode images and then perform multimodal fusion. Now, multimodal models by themselves are capable of doing early fusion using byte transform models like Wilbert, VisualBERT, LXMERT, and so on. In this work, our idea is to basically study, hateful comments in the context of videos. So in some ways, we are also doing hate speech detection using context. However, hardly people have basically looked at the comment text in the context of videos, which is the gap that we fill in this work. So to be able to do this work, we first contribute a hate comments dataset. So this hate comments dataset is basically derived from videos, English videos with English comments in them, taken from YouTube and BitChute. Videos essentially are less than 10 minutes in size. We use YouTube API to collect metadata, including title and description. We extract the audio part of the videos and then use Microsoft Azure speech to text transcription service so as to essentially gather the transcript information. Now, when you get these comments, they need not necessarily be hateful. So therefore, we have to get manual annotations done. We got them done as hate versus non-hate for original comments. However, we realized that there was a massive imbalance in the hateful versus non-hateful comments, and therefore we also asked annotators to actually come up with manually come up with some more hateful comments. Now, they were asked to come up with such comments such that the generated comments were either paraphrased original comments or comments inspired by the natural course of discussion in the comment section of the video. So they are also requested to follow the same style as was there in the other comments on the video. So contextual dependence of hate in comments. So we ensured that in the data set, comments by themselves are not toxic. If you just look at the comment text, we ensured that if you use Perspective API, then these comments receive a score of less than 60% as compared to the recommended 70% across all toxicity dimensions, which include toxicity, obscenity, insulting, and threatening. Now, we study two different problems as part of this work, hate speech detection, hateful comment detection, and hate target type labeling, right? A hate target type detection. So target type classification. So as part of hate comment detection, this is how we define a hateful comment, three different parts. So if it, a comment is hateful, if it basically uses extreme words such as against an individual, community, location, or organization, or it spreads misinformation or fuels a controversial discussion or instigates a target with the purpose of maligning them, or it is about any unproven claim against a target with the intent of maligning. So in political or controversial cases, we ask the annotators to verify this information online using a direct web search. If this information has been proven or validated, then it should not be marked as hate, right? So for target type labeling, we ask the annotators to identify any of these four targets: community, location, individual, and organization. A single comment can actually be hateful to multiple target types. For example, some of these comments can be hateful to more target types like organization and community in this particular case. Now, to be able to select the right target type, we gave the following guidelines to the annotators. So for community, it should be hateful towards a whole fraction of society. Location, it should be hateful towards a specific area like North Carolina or India. Individuals, it should be targeting specific person. Organization, it should target a specific organization. So for example, a particular video, have a look at the links in the original paper, but for a particular video, if it basically is targeting Indians to call center, associating Indians to call centers, well, that's a problem with the community. Or a toxic comment on how India is destroying crops. Basically, that's basically about location, or hate against women in the video, a particular woman in the video. It's basically about a specific person, or associating McDonald's food to toxic things. It's basically organizational hate, right? Hate towards an organization. So our data set contains about 1,000 hateful comments and about 1,000 non-hate comments derived from 401 videos with an average of about 5 comments per video. 62 videos from BitChute, remaining from YouTube. Videos belong to 8 different categories, so as to have diversity across different categories: news and politics, cuisine, sports, health, entertainment, fitness, religion, and fashion and beauty. Target type, again, there are 4 different target types spread across different. Well, there's a reasonable balance between location and organization, but then they are much lesser compared to community and individual. So this is the natural target type distribution. There are more comments targeting community and individual, right? So we divide the data set into train, test, and validation. So comments from the same video could go into any of these. Some 1,000 plus comments, 1,100 or so, 1,200 or so comments in the train set, and 470 in validation, and test set contains about 400 comments. This data set is too small, therefore we augmented the train set using back translation and the Parrot API. Now, as part of our method, we fine-tuned BERT large case models, encoder model, 24-layer transformer-based model, right? 40 epochs, Adam optimizer for optimization, right? For training, right? We only trained the last layer of the BERT model while we kept the other layers frozen, right? So that's that. We use several features. So text-based features include comment only. So from the comment, we removed links and mentions. We replaced emojis by corresponding expressions, keyword expressions and sentiments. Yet another thing was to try out video titles. We also tried description key phrases by finding key phrases using keyword library. Right? We also found key phrases from transcript and used them as input to our model. These features are all combined or concatenated and separated using a separator sep delimiter. We also tried visual input-based features by using clip VIT model. And the way these features were obtained as follows. We found very important frames, those frames which basically have higher cosine similarity in terms of embedding space obtained using clip VIT with respect to the comment embedding. Right. So we took top 5 most similar frames and we took their average embedding of size 512 and used as an extra input for our BERT large model. Now, how do the results look like? So if we look at only comments, well, so here are the results. These are the results without visual input to begin with. We show precision, recall, F1 score, and accuracy. So we experiment with different combinations of inputs, comments only, comment plus title, comment plus transcript key phrase, description key phrase, and so on. Right? What we observe is that if you just use the comment, you get a very poor accuracy of about 60.8%. Right? However, if you basically add whether you add title or transcription key phrase or description key phrase, all of them help, right? All of them basically help you improve accuracy on top of comment only. However, a combination of title plus a description does not really help much, maybe because they're redundant with respect to each other. Now, the best method essentially is this one, which basically gets a 76.3% accuracy, where we use a description key phrase and transcript key phrase along with the comment. Now, of course, this easy to explain. Descriptions and transcripts contain complementary information, and therefore this leads to the best results. Adding the title further does not really help more. Right? Now, in this particular case, when we pass input to the BERT large model, the overall size limit may be input max sequence length may be a problem, and therefore we make sure that all tokens related to comment are passed. However, description key phrases are limited to 80 tokens, and the remaining space is filled using transcript key phrase tokens. Now, how about the results with visual input? So when we add visual input, so this part of the slide is basically from the previous slide. These are the results with visual input. We observe that across all of these combinations, we observe that, in general, the results improve with the visual input, thereby emphasizing the importance of visual input for this task. However, what we observe, if you look at the best model, it's basically 78.6% compared to 76.3, which is the best that you could obtain using without visual inputs, right? Thus, visual input is really important. But this best accuracy is obtained using just the comment plus description key phrase, thereby thereby proving that the transcript basically becomes redundant when you also pass the visual input. Now, how about hate target type prediction? So we take our best model from the hate comment detection task and essentially use that for hate target type prediction. What you observe here is that the model is able to predict the individual and location classes with a higher accuracy compared to the community and organization types. We also observe that the overall model basically achieves a score of AUC score of about 0.61, and that basically shows that there is a significant room to cover in the future. We also did qualitative analysis of our model, and we found so these are some of the failure cases. So these are the failure cases for hate comment detection task, and these are the failure cases for hate target type prediction task. What we find is that these two cases are basically cases where the predicted label was non-hate, but the actual label was hate. While these are the two cases where the predicted label is hate, while the actual label is non-hate, right? So in most of these cases, we find that understanding hate requires some external knowledge or other comments related to the video to completely understand the logical reasoning chain. And that is why we think that our model sort of fails in recognizing these things. For example, saving animals is in general, non-hateful in general, but then this video was about beef consumption, and therefore saving animals is contradicted to hate consumption, and therefore, true label is sort of hate here. But in general, it is non-hateful, right? So there are some subtleties and some external knowledge that could sort of help relate one concept to another, and thereby help the model in completing the logical chain. Okay. The similar kind of scenario we observe when we try to do hate target type prediction. In some cases, for example, this one, the true category is community, but the model also predicts individual as an extra category. Similarly, here the hate is towards a particular individual Putin, while the target is while the predicted category is community. Right. So that's that. We performed a further qualitative analysis in terms of attention visualization. So this is basically the comment is white people in their finest moment, the same comment that I showed in the beginning of the video, right? We observe that the dark red color essentially means more importance was provided to these parts of the text when coming up with the final class label. And we observe that each part of the context, whether it is just the comment text or the description key phrase or transcription key phrase, they are all important in terms of identifying the right category, right? We also show visualization, top three images or top few images that have been extracted for a particular comment, when we use visual inputs as well, right? So the top images retrieved by the clip model, clip VIT model for the comment seems like a rumble in the jungle with a hippo and a gorilla, right? Now, here, of course, the comment calls Steve Harvey a gorilla and Graham Elliott hippopotamus. What is very interesting is that of course, the model extracts these two frames, which are really relevant to the comment embedding. However, it is also able to extract this frame, which in general is not the target of the comment, but the model basically retrieves this frame. Although it doesn't have Steve Harvey and Graham Elliott, but it can also be referred to by the comment, right? And therefore, we believe that the model also handles visual inputs very nicely. So in conclusion, in this work, we propose novel tasks, hate comment detection and hate target type prediction for hateful comments. In this work, we also propose a novel data set, which contains English videos from two different websites, YouTube and BitChute. We showed some baseline results with qualitative analysis. We observed that visual inputs help. We also observed that video description is important, both in the with and without video, with and without visual input use scenarios, right? And we also make our code and data publicly available. So we invite people to experiment with this data and come up with more accurate models. Hope you like the work. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.